Hi everyone, welcome to another episode of my tutorials on Nextflow for Bioinformatics. In this video, we are going to look at how to generate RNA-seq read counts. So that means we will get our RNA-seq data and then we are going to generate read counts. All right. So this is what we are going to do. We are first going to get our example data sets. We are going to use fastqc files. These are paired end reads. Of course, we will deal with multiple samples. Then we are going to trim the reads, and then after trimming the reads, both the raw reads and the trimmed reads, we are going to run QC on them. Okay, we are going to use fastqc to do this. So the essence or the point is to compare and then note if there was an improvement in the trimmed reads, okay, compared to the raw reads. Then for the trimmed reads, we are going to map those reads to a reference sequence, and then after getting the BAM files, we will generate the read count. We are going to use feature count. So for the trimming, we will use trim galore. For mapping, we will use star. For the read count, we are going to use feature count. Of course, for QC, we are going to use fastqc. That's what we are going to do. We can also go ahead and use multiqc to aggregate the fastqc reports. All right. Okay. So this is what we are going to do for the tutorial. At the end of the day, this is what we are going to generate. I'll have to pull this up for you. So by the end of this tutorial, that's what we are going to generate. All right, so we have everything here. So we have our read counts. So all the samples, these are the samples. So the script we are going to use will aggregate everything for us like this, and then we are going to be fine. So once you have this, then that means that you can proceed to do your differential expression analysis using tools like the seq2, HR, etc. All right, so we need to start from this section. So for the script we are going to use, I've already prepared them. The script is here. So we are going to go through these commands line by line, and then I will explain everything for you so that you can also reproduce it. For those who want the script itself, there's a link you can use to get the script. So just check the description box, you'll find the download link to get the script. And the script works on multiple samples, so you don't need to worry about anything. So just download it and then run on your example dataset. So that's what we need to do here. Okay, now getting back to the overview, we need to also note the PC requirements. We are going to use Nextflow to do this, so we need to make sure we have Nextflow installed. We also need to make sure we have fastqc, multiqc, trim galore, star, subread. These tools also need to be installed. You can make your life easy if you have one of these, Conda, Mamba, Micromamba installed. We can use any of these to install the rest of the tools. And so I will recommend you have one of these installed, preferably Mamba or Micromamba. These ones are faster when it comes to installing tools. So just check the description box. You'll find links to videos that show you how to install these tools, Conda, Mamba. All right, so just check them and you'll be okay. All right, so if you have all these tools already available, then great. If not, try to use one of these three. All right, so without further ado, let's get started. So we will move to the terminal and then proceed. Okay, what we are going to do next is to install the tools we will need for this exercise. I am going to use Mamba to do this. If you have Conda too, you can use Conda. If you have Micromamba, you can also use Micromamba. So any of them should be fine. I'll use Mamba. That is faster compared to Conda. So that's what I'm going to use. So I'll type Mamba and I'll create an environment. So I'll say Mamba create -n, and I'll give the environment's name. So the environment's name is RNA-seq. This is the name of the environment. I repeat, Mamba create -n RNA-seq. The environment's name is RNA-seq. Then I'll specify channels. I'll say -c, bioconda -c, conda forge. Then I'll specify the tools I'll need. I'll need Nextflow, so I'll have it available. Okay, so I need to install that. I'll need fastqc. I'll also need multiqc. I'll also need trim galore. So there's a spelling, trim -galore. I'll need star, I'll need sub read. These are the tools. So we'll need Nextflow to help us run the pipeline. We will need fastqc and multiqc for quality control. We are going to need trim galore for trimming the reads, star for mapping, and then sub read for the read counts. We are going to use feature counts, which is part of the sub read package. So let's execute this command to create the environment. All right, so we can type Y for yes to confirm. And once we do that, the necessary packages will be downloaded, configured, and installed for us. So we just need to wait. All right, so all I have to do is just wait for everything to get done for us. Okay, the tools have been installed. So if everything is successful, you are going to find this text coming up to tell you how to use the tools. So because I use Mamba, I'll see this text. It says Mamba activates RNA-seq, Mamba deactivates. So if I want to use the tools, I need to activate the environment using this command. If you use Conda to install, you are likely to see Conda. If you use Macro Mamba, you are likely to see Macro Mamba. So the point is, once you see a message like this, everything is okay, so you can proceed. Okay, now I'll need to activate my environment. So I'll clear the screen and I'm going to say Mamba activate RNA-seq. Perfect. So it has been activated. So that means we are done with the software installation. So we can proceed with the next activity. So I'll clear the screen again and then I'll proceed. Okay. So what we need to do next is to create a working directory and then we are going to cd into it. So this is a project. Let's take it that way. So I'll say make dir and I'll say RNA-seq. You can use any name of your trust, that's also fine. So you can use uppercase, lowercase, that's fine. But I'm keeping it simple here. So this is going to be the directory where I'll work in. So this is my project directory. So I'll create it and I'll say cd RNA-seq. Nice. So I have created that directory. So we can proceed. So what we need to do next is to download the example data. All right. So for the example data, I have already prepared a script that we can use to get the data. So let's check here. Let's go to this page. This GitHub report of mine. So this is the script we'll use to get the data. All right. So this data, this is the paper that published the data. So I will leave this link in case you want to check this paper out. So I'm using their data to do this exercise. So the commands here, one command gets the data, processes it, and then gets the needed files for us. And then we have other things here, basically. So anyway, that's how we are going to get data. So when you come to this page, download the script. So the link to this page is in the description box. I repeat, the link to this repo is in the description box. So when you are here, I want you to come to raw and then right click. So we will right click and get the link to this script. So copy the link, this link. So right click and then copy the link. Alternatively, on this page, you can click raw. So when you click on raw, you'll be sent to another page. So there's the page. So when you are here, just right click and get this link. So there's the link that we need. So this is what you need to copy. So let's copy this link and then move to the terminal. All right, so we are on the terminal now. So what I will need to do is to use wget to get the script. So I'll say wget and I'll supply the link to the script. So there's the link. So I'll just hit enter to download the script. So if I do an ls now, I'm going to see the link. I'm going to see the file, basically the script. Let me put it that way. So this is the file that we need. So because there's a script, we need to first add permission rights. So I'll say chmod plus, okay, let me just do it. So it's chmod plus x. You know, if you type just chmod, that's what comes. It tells us missing open. We need to specify a file. All right. So we have to do this. So we have to say chmod plus x, and then we specify the script. This is it. So chmod plus x, and then we say get data.sh. So if I do an ls now, because I'm on an Ubuntu system, it's changing the color for me to let me know that this is now executable. All right, so this is how we are going to do it. So just make sure to get this done, and then you can proceed. All right, so let's clear the screen. Let's do an ls again, and then let's execute the script. All right, so once we execute the script, it will get the data for us. So I'll say /get data.sh. So when I do it this way, it will start getting the data for me. So all I have to do is to wait until everything is done. Perfect. The data has been downloaded. Please take note that with the data, depending on the internet speed you have, it will take a shorter time to download. All right. So once it's downloaded, you will see these texts or these tests coming up. All right. So I'll clear the screen. I repeat, when I clear the screen and do an ls, I'm going to see something like this. Okay, so you are going to find the fastqc directory, you find web directory. You're also going to see the data itself, which is here. So this is what you are going to see. All right. So the script basically downloads and then extracts the needed files for us. So in the fastqc directory, if I say ls fastqc, I'm going to see my fastqc files. If I do ls into ref, I'll see my reference sequence. All right, so this, what we are dealing with are human genomes. So basically we are using the chromosome X of the data, and we have the FASTA file and the GTF file for the reference sequence. So these are the information we need. All right, so we can now proceed with the rest of the exercise. All right, it's now time. Okay, so now we are ready for the scripting. Now I'll go over the pipeline again. There's a simple pipeline. I'll go over again and then highlight a couple of things here. So before you write your Nextflow script, you should already have a plan of what you want to do. It's very, very important. You should already have the series of steps you are going to take. All right, and then you can now put it into implementation. That is where you write your script in Nextflow. So that means your command should already be working before you can put it in Nextflow. Nextflow is a means to an end. All right, and so you should make sure that everything you are doing, you know what you are doing, the steps work, and you get your desired outputs. So that's what you need to know. Now, I'll also talk about this. So in this workflow, I have fastqc, I trim before map and then reading. All right. And I also do QC. When it comes to the trimming, it depends on, it's situation dependent. It's not always that you have to trim. You need to first assess the quality of the reads. You can do for some of the files just to make sure they are okay. If they can be improved, then you can add a trimming. So the trimming here, I added it because initially I did some checks and I realized that the reads can be improved. We can improve it by removing low quality ends, the low quality ends. So that's why I had to bring it. But in some situations, you can still use the raw files themselves and then do the mapping and then do your read counts. Okay, so it depends on what you want to do. So you should always contact or consult your informatician to help you design a workflow. Alternatively, in some institutions, so they already have a working pipeline, so they just go by those steps and then that's fine. So that's what you need to know. Okay, so I will go back to the terminal and then we will start the scripting. Okay, so this is what we are going to do. Now for this tutorial, I will just do a couple of things here. I will do this. I will blend with my GUI. So in the script, we need to get our data. We already have the data, which is here. And so now we have to write the script. So in the script, we will do trimming, we will do mapping, we will do read counts. All right. So when it comes to the scripting with Nextflow, you can start, you don't necessarily need to start from trimming. It depends on how you want your information to flow. All right. So I will start by giving some guidance and I'll proceed with what I want to do. Okay, so I can do the trimming, which is the one I have to do first. And of course, after trimming, then we will now do mapping. We also have QC and stuff. So that means that in this script, I will start with trimming. So in trimming, we are going to use trim galore. That's what we are going to use. So first of all, I'll just say touch to create the script. So the script, I'll just say rnaseq.nf ls to see the script. This is the script. It's now blank, it's empty. And so because it's now blank and it's empty, I will now have to supply the information, all right, that I need in it. So that is what we are going to do next. All right, so let's do this. Now in this script, we will need some inputs. So as a way to test run the script, I'll first start with getting the input first, and then we can now start with the main activities. So I'll do this. I'll say nano rnaseq.nf and then what I'm going to do is to just type workflow. All right, and then I'm going to put in some information. So with this script, we will need some inputs. So one of the inputs we will need is our reference sequence, the FASTA file. We need that information here. Okay, so I'll put that here. So I have ref underscore FASTA or FASTA, whichever one you call it. So I'll say equals channel dot from path. Now say params dot ref underscore FASTA. And I also need GTF. So I'll say ref equals GTF equals channel dot from path params dot ref GTF. Now in Nextflow, you can force Nextflow to do some validation. That means that you can tell Nextflow that it should check if these files indeed exist. It's possible to do that as well. Okay, so for this tutorial, because I want to make it simple, I will try to minimize the codes, but going forward, if you are looking to develop expertise in Nextflow, there are things you also have to add. When you check the standard pipelines, we have them there. All right, so just take note of that. So this helps you along the way. Okay, I'll also need my raw reads. All right, so those ones can come in. So I can also say fastqc underscore ch. These are all channels. So these are all channels. All right, so channels aid in data flow. Okay, so here I can say ref FASTA, ref GTF. Here I can say fastqc. I mean, the names are there, it can be descriptive, but I'm just putting this one there just for you to know. So I'm going to try to use different names just to let you get used to giving different names, using different naming styles. All right, so fastqc equals to channel.from file pairs, and here I'll say params dot reads. I'll need this information. All right, so we need to take note of that. Another information that I would need will be this. I'll put it here. So that will be strandedness of data. So here I'll say strand equals channel dot from. Now that's going to be off. So channel dot off. Now say params dot strand. I also need this. Okay, so just take note of that. So params dot strand. I also need this information. Okay, so some of these things are for testing. All right, so we will later do some modifications in there. Okay, so now when I come here, I'll just say ref FASTA dot view and then ref GTF dot view. I'll start with these ones first, and I'll say strand dot view. I need this. Okay, so strand dot view, Control X. We need to make sure that the curly brackets are all matching up. So that's what we should have. And then I'll just say Control X. I'll just do this. Okay. So now I'll just do a test run. I'll say Nextflow run RNA-seq, and I'll say --ref faster, that is in what, ref /chrx.fa --ref gtf is what, ref /crhx.gtf, and I'll have what, --strand. In this story, we are going to use 0 for the most part. I'll explain this later on. All right, we are going to use 0. And I'll also add --width. And that will be what? That one will bring it in code. So that will be fastqc / curly bracket _1, _2 curly bracket *fastqc.gz, and then that's in quotes. For this format, I've explained this in a lot of my Nextflow tutorials, so just check the videos out. You will get the explanation for these things. Okay, we are dealing with paired and width, so that is why we are using this format, because we have read 1 is represented with _1, read 2 is represented with _2. So this is a way to let Nextflow get the paired and width, the width in pairs, read 1, read 2. Okay, so I'll run this command. Okay, so when I run it, there's what I'm going to get. All right, it tells me the reference file, the FASTA file, the FASTA file, the GTF, we have it there, and the strand, which is 0, we have it there as well. So that's also good. Now I will add the fastqc. So nano. Okay, I'll add it again. So I'll just say here, I'll say fastqc _ch.view. We will check them out. So I'll run the script again like this. And then once I run it, I'm going to see something like this. Okay, so these are the inputs. This is what we are going to need. All right, so just take note of that. Okay, so that's basically about it. So the commands we are going to be using, whenever I run Nextflow, I'm going to supply all these. All right, so take note of that. So I'll need fastqc file, this and this. Of course, for some of the tasks that we are going to do, we don't really need to have all of them, but since this is a script that I'm designing in such a way that you have to supply all the information and to do everything for you, we are always going to be running it this way. All right, even though when I'm testing, depending on the process, some of the inputs may not be used, but I'll still run everything in this format. All right, so but for those who want detailed explanation for Nextflow, you can always reach out to me, and then we'll see how it goes. Okay, so that's it. So let's proceed. So let's clear the screen, and then let's proceed. Okay, now we've done a test run. Everything seems to be fine. So I'll do nano RNA-seq, and I'll clear some of the information. So we don't need the .view. All these ones, we don't need them. I only did it to make sure that my input files are there. Okay, so that is fine. So I'll exit, and then we can proceed. So let's look at the pipeline again. So I have my input files, fastqc files, FASTA files, all those ones, I have them. Now, what I'll need to do next is to trim. I'm going to basically do trimming here. All right, I will trim the files, and I'm also going to run fastqc. Okay, it's important. So what I'm going to do is that I'm going to do the trimming, and then I'll aggregate both the trim reads and the fastqc, and the raw Pascal files, and then do the QC on them once, so that in my reports, I'm going to see all of them there. Okay, so I'm going to do it that way. All right, so let's see how that will be done. So I'll start with the trimming. So I'll move back to the terminal and then we will check. Okay. So for the trimming, we are using trim galore. So let's open the scripts and then let's do this. So trimming will be a process. So for those who don't understand process, I have tutorials that explain them, and I'll also give you the Nextflow page that explains process. So I'll use process and I'll say trim galore. Now I'm using the tools, the names of the tools to do that. All right. So process, I'll bring my curly bracket start end, and then here I'll specify what I want to do. So I'll say publish dir first. I'll bring my double quotes, so trimmed, and I'll say mode copy. So that's what I am going to do. So the reason why I'm doing it this way is that Nextflow has a directory where it places the outputs. So if you want to customize your outputs, then you have to bring the publish dir so that it makes a copy of the outputs to the directory. So in this case, it is trimmed because we are going to trim. So the output name should be descriptive. Okay. Then my inputs will be val. It will be tuple first. Let me just correct it. So it's going to be input to be tuple. So the value as sample ID and the path, that will be the reads. So when we use the paired and reads, Nextflow gives us a sample ID as well as the reads themselves, i.e. read 1, read 2. So this is how Nextflow will put this information or supply it to the process stream. Now for outputs, you will need path, and we'll bring this. All right, so that's what we are going to. So this is going to be the path. Star, we are generating. We want Nextflow to take record or to acknowledge all files that will be generated. Another one, path, double quote star trimmed star.fq.gz, and then I bring my single quotes, comma, I'll say emit colon trimmed. Now here what we are doing is that we are also putting this command because we want Nextflow to also take notes of output files that have this pattern. So they should have trimmed in their names, and they should also what have .fq.gz. Okay, now this I'm doing this because trim galore, this is how it generates its files. All the files it generates, or the command we are going to use will generate files that end with .fq.gz. So you need to also know the output that is going to be generated by your files, your tools. You need to know the output so that will help you to put in additional measures. The emit trimmed means that this is kind of like an alias. So that means that in this process, we have a label called trimmed, and this label called trimmed is linked to all files that have trimmed in their names and that also have .fq.gz as their file extensions. So it's a way to kind of label some files based on their patterns. So that's how it's going to be. Now, once we are done with this, we can now do this. We can now bring our script. I'll add the spaces. So script colon 3 double quotes, or let's say triple double quotes, another triple double quotes, and in between we will put in our commands. So we are using trim galore here. So I'll say trim underscore galore dash kill 20 dash dash paired I can even bring the dash dash paired first. I'll say dash dash paired dash kill 20 dash dash gzip. I'll explain everything. Dash dash base name, I'll say dollar sample ID, all in curly brackets underscore trimmed, and I'll say dollar reads. All right. Now for traumatic, all right. If you are dealing with paired and reads, you need to let it know. So hence we add in paired. Now we are also going to trim. We are going to do quality trimming. We are going to trim the end of the reads. So this is the threshold, kill 20. So the kill, that's the quality, the first call. All right. Default is 20, but I just thought I will specify it again for you to know that it's possible to do that. By the way, I have a separate tutorial on trim galore. So for those who want further explanation on how to use trim galore, just check the description box. The link to that video is there. That gzip means that the output should be gzip. That's basically what it means. Of course, with this one too, there's a caveat. So just check the trim galore page and to let you know what to do. Okay, when and when not to use dash dash gzip. We also have dash dash base name. That tells trim galore that the output files should have this name. So basically, it's more like a prefix in addition to whatever name that will be added. And then we add our read1, read2. So the read1, read2 are in this variable reads. Hence, we have this here. All right. So this is how we start this Nextflow script. So we are starting with the trimming. All right. So just take notes of that. So this is what we have. So I'll type Ctrl X, I'll save it, and I'm going to rerun the script. All right. So I'll just do this. I'll recall it again here like this, and then I'm going to run it. So here it's dash reads. I think I'll just minimize for you to see first before you proceed. So let me just change it and make it 18 to see. Okay, so it's dash reads. You have your single quotes, and then you have your fastqc / all these things. Okay, so you need to take notes of that. All right. So I will still put the instruction how to run the script in the description box, so you don't need to even worry. I'll reverse back to the font size that we were using. So this is what we were using, so I'll just go with this. So I'm going to rerun the script, and then let's see how it goes. Okay, so let's wait and see. Okay, so now when you run the script, you are going to see that nothing has been displayed. All right, this is because we need to specify the process trim galore in the workflow section. All right, so let's edit the script again, and then let's specify trim galore in the workflow. So I'll scroll down and I'll do that. All right, so when I'm here, what I'll do is to say trim galore into brackets, and I'll say fastqc_ch. This is it. Now I'll assign the entire operation to a variable. So I'll say .set curly brackets, and I'll say trimmed. All right. Now exit, and I'm going to run it. So I'll run it again here. So let's see how it goes. Perfect. So now you can see it's running, and it tells us 0 of 12 because we have 12 samples. So let's wait for everything to get done for us. All right. Trim galore has done its work. So now if I do an ls I'm going to find a directory called trimmed. If I ls into trimmed, I'm going to find my trim reads, which are these ones. Okay, so we see all of them here. I can even do ls trimmed star.fq.gz to list the files. All right. If I just do ls, I'll also see the reports in addition to the trim reads. So we see them here. So these are reports that you can also view. All right. Let's clear the screen. I can say cat trimmed. And I'll just specify one of them like this. Let me just use this. So I have this. This one of the reports. I can just do a cut and I'll see what is here. So this also lets you know what has been done in terms of reads that have been trimmed, those with adapters, etc. So you can read more to see what has been done, what processing has been done, what information has been removed from the data. So it allows you to better understand your data and appreciate whatever is going on. So you need to take note of that. So for this tutorial, I will skip the examination of these reports and I'll proceed. So the assumption is that the trimming has improved the quality of the reads, all right, the overall quality. So that's what we need to take here. Okay, so that's for the trimming. Let's clear the screen. Let's ls into the trim directory again. I'll say star.fq.gz. All right. So after trimming, what I plan to do is to run QC on the trim reads and also do QC here. So I'll say ls fastqc and also do QC, okay, on this as well. So I'll do the QC for this and I also do QC for this and then compare. Okay, so this will come at a later stage. Okay, so let's look at how that can also be done. So let's proceed to do that as well. So to do the QC, all right, and then compare both trim reads and then the raw reads, this is what we need to do. I'm going to let you know what we are going to do now. So if we want to run QC, what I want to do is to first aggregate all the files, both trim reads and then the raw reads. I'll aggregate all of them together and I'll run fastqc as well as multiqc on them. Okay, so that is what I'm going to do next. So just take notes of that. So let's do that now. So that means we'll need to have a way to combine this, and I'm going to show you how to do that in Nextflow as well. So let's edit the script and then let's proceed. Okay, so let's open the script again. And then what we need to do is to add fastqc. Okay, we need to add a new process called fastqc. So I'm going to put that process somewhere here. So I'll just say process and I'll say fastqc. We can also say QC. That's also fine. Okay. Now in the context of this video, let's even use QC rather. So I'll just say QC and that should be fine. All right. So I'll just say QC and then I'll just do this. Again, here I'll also use publish dir. So I'll say publish dir and I'll say QC reports. All right, comma mode will be copy. Now for the inputs, it's going to be reads. So I'll say path into brackets reads. And then for the outputs, path star everything. Nextflow should take note of every file that will be generated. And then in the script, triple double quotes and that triple double quotes, and in the quotes, we will now add our command. So here we are going to run fastqc and we will run multiqc. So I'll say fastqc dollar curly bracket reads. Then I'll run multiqc and I'll say star fastqc star. All right, we need this because multiqc will aggregate the report for us, so we need this as well. Now in the next line, here's what I'm going to do. I'm going to say make dir and I'll say fastqc and I'll move all the fastqc report into it. So I'll say mv star fastqc star and I'll move it to fastqc. The reason why I'm doing this is that I want to separate the fastqc report from the multiqc reports. So after running fastqc and multiqc, I'll just separate them. So basically this is what we are doing here. Okay, so this is going to be it for the QC. So I'll just do this. So this is how it's going to be. All right. Now we need to add this to the process, the workflow, the section. We need to add the process QC to the workflow section. So that means we have to scroll down and then put that also here. All right. So here it's getting interesting. All right. Now we have our frame rates, we have our raw rates. So the question is, how do we aggregate all of them together and then push it to the process QC and then redo it? Okay, so that is what we need to look at next. Okay, so let's just make sure we have that done. Okay, now I'll just go over because I want everything to be descriptive. What I want us to do is to just rename this again, the process. Okay, so here you can say fastqc and you can also say fastqc and multiqc. All right, but let's just keep it as it is. So let's proceed. So when I come to the workflow, I now have to find a way to combine both files. Okay, both groups, that's the raw reads as well as the frame reads. So that is what we need to do. Now you will notice that in the trim galore section, we added the emits. So the emits here was for all the trim reads. So we have an alias for them, a label for them. All right. So that will help. So when we come to the workflow section here, what we are going to do is to do some further processing. All right. So here, what I'm going to do is to say fastq, or instead of fastq, I will just make it descriptive. I will just say raw fastq equals, and then I'm going to process this fastqch, this channel. I'm going to process it. Okay. So what I'm going to do is to say fastq underscore ch dot map, and I'll bring curly brackets, and in that curly brackets I'm going to do my stars. So I will say items, I'll bring a minus and a greater than symbol, and I'll say items 1. All right. So the reason why I'm saying items 1 is that with the fastqc, it returns the sample ID as well as the fastq files. So what we want now is just the fastq files, and this is the index that will allow us to get that. So we have 1 that will allow us to get just the fastq files, i.e. with 1 and with 2. So that is why we have it this way. All right. So now that we are done with this, we can say dot flatten dot collect. We want to squash everything together into a single list. Now we'll come to trimmed fastqc. That will be equals to, we set the variable here. So that will be equals to trimmed dot flatten dot collect. All right, so we have both. So now that we have both, what we need to do next is to now bring all of them together. All right, so here I will just say raw underscore fastqc dot mix, and then into brackets trimmed underscore fastqc, and then I will say dot collect. Then I'll bring a pipe and I'll say QC. So now I'll exit and then save changes. Okay, so I am now going to rerun. So I'll execute the command again. So I'll run it again. So let's see. Nice. So now Nextflow is currently running. So we just have to wait until everything is done. So here, let's also look at this. The first process is trim galore. Second is QC. So ideally, for processes, it's advisable to include the names of the tools if it's possible. So for example, this one is trim galore, so I know this is what is running. Now when it comes to QC, we're running fastqc and then multiqc. So you can just name it as fastqc underscore multiqc. All right, so this helps you to keep track of things. It allows you to know which tool or which tools are running at a point in time. All right, so I also do that just to keep me organized, but we can still use the QC, that's fine. Okay, so these are things that in your journey you may want to consider to help you keep track of things. Anyway, so let's see how this goes. So this may take about 4 minutes, so you just have to wait for everything to get done for you. Okay, the QC has also been done. So now let's clear the screen. Let's do an ls. We are going to find a directory called QC reports. So if you ls into that directory, you are going to find fastqc, you are going to see multiqc reports. Let's ls into qc/fastqc. We are going to find the fastqc reports. Okay, we are going to find the fastqc report for the raw fastqc files as well as the trimmed reads. Okay, so let's even do this. Let's just examine these files before we proceed. So let's go to QC reports. So let's just take a look at the fastqc reports. We will look at one of them, trimmed and then raw. So this one, for example, this is the raw data. So let's open this. Here's what we see. And then let's also open the trimmed, which should be here. So we have var1 that's trimmed. Yeah, this one here. So open it, and then you can even compare, right, to see what you have. So this is the raw data. Look at this. There's the trimmed. We also have that also here. So you can compare and you will see there has been a change, because if you take a look at this one, for example, it moves up to this region here, but this one has moved a bit. So they are all mostly in the green region, which is high quality scores. But for this one, you will realize that we still have some of them moving here. So in general, the sequencing quality has been improved. All right, so this is as a result of redoing the trimming. All right, so That means that the pipeline we have is okay because the trimming has improved the quality of the reads. So that means we can still add on. All right. So ideally, what you have to do is to just do a quick analysis where you can pick some of the files, run fastqc, and do some trimming just to make sure everything's okay. Then you can put it in the pipeline, or in the pipeline itself, you can decide to make trimming an option, whether you want to trim or you still use the raw reads. All right, so these are things that we can talk about later on. So it's possible to do all these things in your Nextflow script or pipeline. All right, so these are things that we will talk about later on. Or for those who also want extra tutorials on Nextflow, just let me know. Just send an email or book a consultation, book a session, and we are going to work on that. So far, so good. So let's proceed. Let's go back to the terminal, all right, and then continue. Oh, and before we proceed, let me also say that the multiqc report is also here. That allows you to aggregate the report. So you can aggregate, and this is what you get. All right, so there's the multiqc reports that lets you aggregate the fastqc. So you have report for both raw and then trimmed reads. All right, so just take note of that. So let's get back to the terminal, and then let's clear the screen. Let's do an ls. Let's proceed. So let's look at the pipeline. We have our fast raw reads. We've done the trimming, and then we have been able to do the QC for both raw and then trim reads. We've realized that the trimming improved the reads. All right. So now we can proceed with the mapping. So with the mapping, we are looking at star. We are going to use star for the mapping, and we are going to generate the read count. Now, when we are using star for mapping, all right, so you need to first generate an index. And after generating your index, you can now do the mapping itself. I have a separate tutorial which shows how to map with using star. So for those who want a detailed explanation of how star works, just check the description box. You will find a link to that video. So let's proceed. So now we'll go back and then continue. So with the mapping session, we are first going to start with indexing, and then we are going to do the mapping itself. So let's take note of that. All right, so let's move to the terminal, and then let's do this. So we will open the script again, and then we'll proceed. We have done our trimming, we have done our quality control. That's great. So what we are going to do next is to do the mapping. So with the mapping, we will start with indexing. All right. So to build the index, we need the fasta file and then the GTF of our reference sequence. We have them already. So star is also a splice aware mapper. We are dealing with eukaryotic genomes, so it's advisable to use a splice aware mapper, and that is what we have now. All right. So we will start with the indexing. So I'll start with a process for indexing. So I'll say process star index. All right, I'm going to name it this way to make it short and simple. I bring my curly brackets before and after. Then I'll put in this. I'll say publish dir. I'll say index. You can also say ref index, whichever one you want. That's fine. It depends on you, by the way, but let's say index to make it simple. Comma mode copy. In the next line, I'll say input colon. When I come here, path is going to be fasta file. We will need this input. The next input path is going to be the GTF. We will need this information. When we come to the next line, which is output colon, we'll say path space double quote star double quote comma, and I'll say emit. Again, we are using the emit colon, and I'll say index. So here what it means is that what we are going to generate, the output, we are giving it a label called index. This allows us to call it. I repeat, this allows us to call the outputs later on in the script, because after indexing, you will do mapping. So mapping will require the index, okay, the files that have been generated. So this is the emit function or emit. Okay, now in the script, let me just do this. So in the script, let's do this. Colon, when I come down, my triple single double quotes, another triple double quotes, and inside I'll use star. So for star indexing, you will say star. That's how we run star. Dash dash run thread n to specify number of threads. Here I'll use 8. So run thread n. Now I'll do this. I'll bring 2 double slash. So I'm doing this because the command is long. So what we want to do is to keep our script tidy by putting some of the commands in, or let's say by splitting the commands into separate lines. So to allow Nextflow to recognize that the continuation of the commands are in the next lines respectively, we will bring 2 double slashes. Okay, so this is how we specify that the command continues in the next line in Nextflow. For normal Linux system, it's a single one, but for Nextflow, it's 2 slashes. So the next line, I'll say dash dash run mode space is what? Genome generates. So we have star run thread n. Run mode is genome generates. We should take note of the spelling. Space 2 slash again. The next line we say dash dash genome dir index space dash dash. All right. So here the directory for star, you don't need to create it. Once you specify this, it will create it automatically, and then after creating it will place the files in that. So we don't need to create this directory ourselves. The next line, we will add our fastqc file. So dash dash genome faster files. And here we say $fastqc file. Fastqc. So this input here. Space dash dash, not dash dash, this is slash slash. All right. Next line we say dash dash sjdb gtf file. Take note of the spelling. So $gtf. By the way, the manual for star is in the description box, so you can check that link, get a PDF, and then get all these commands also there. Or you can just check the link and get the script and use it once and for all. All right. The other option will be dash dash genome SA index n basis. I will say 12. All right. So this should be fine. Okay. So we have genome SA index n basis. We need to also make sure we have the spelling correct. So just make sure you have it done this way. Okay, so now we can proceed. So we are going to do this. What we are going to do is to scroll down and then add this process to the workflow. Here I'll just do this. So I will scroll down to the section, and we are going to run everything again. We are running everything, and then we'll add the new one, which is the index. So when it comes to the index, we will say star index into brackets. We will say ref underscore fastqc, comma ref underscore gtf. And we will say dot set star underscore index. Okay, we are setting it this way. All right. So when we come to the next line, what I'll say is star underscore index dot view. All right, just to view them. Okay. So technically, you don't even need to do this. Okay, you can just view with the output, but I will still do it here for us to see what is happening. All right, so I'll just do it this way as well, or we can just clear it. So it's supposed to be star index. It's supposed to be star index, and then we say dot index, but we don't need it at the moment. I'll just leave it. It's not necessary at the moment. Okay, so I'll just keep it this way. All right, so let's do this. Let's exit. Let's make sure we have everything we need here. So let's exit, and then let's run it. Now, what you should take note is that after we are done with the indexing, there will be another directory here called index. All right, so let's just rerun, and then we'll see what comes up. So we are going to rerun the script and then see how it goes. Perfect. So now you will see that it has been added. So now we have 3 processes. So it tells us the processes that this pipeline is going to run. So whatever process we add, it's going to reflect here. All right, so this is the power of Nextflow. So let's wait for everything to get done for us. Okay, the mapping has been done now, so we can proceed. So, not mapping, yeah, so it's the indexing rather. Okay, so indexing has been done. We are yet to do the mapping. So indexing has been done now, so we can now proceed. So if you do an ls now, you are going to find a directory called index. So when you ls into index, you find another subdirectory called index, lowercase. So ls into index/index, you are going to find the file. So these are files that star will need when it's going to do the mapping. Okay, so we have generated this, so now we can proceed. Now, what you should note is that with the indexing, in some pipelines, what will happen is that they will omit the indexing parts, assuming that you are going to rerun, you are going to use the same reference sequence, then you don't need to do the indexing anytime you run the script. So you can have the indexing at a particular location and always specify it. There are different ways depending on your objective and depending on how the script is going to be used. For this script, you are always going to rerun the indexing. All right, so that's something you need to take notes. So just take note of that. If you want it modified, you can also reach out to me and we can see how that can be done. Okay, so let's proceed. So now we need to do this. We have the indexing done, so we can now do the mapping, the star mapping. All right, so what we need to do is to open the script, and then now that we have the indexing done, we can add a star mapping to it. So I'll come here, I'll say process star underscore mapping, curly brackets starts, curly brackets end. All right, I do it this way, and then after doing it this way, I'll now say publish dir. I'll say mapping. You can use any name, that's fine, but I'll just keep it this way. So this is going to be the output directory. Comma, I'll say mode, colon, copy. In the next line, I will specify this. I'll specify this CPUs and I'll restrict to 12. So this part is very, very important. All right. It's very, very important because ideally you also want to prevent Nextflow from using all the available CPUs on your computer. If you're running on a remote server with lots of CPUs, fine. But if you are using your own laptop, your ordinary laptop, then you should restrict it a bit so that you don't have the entire resource on your laptop being used. All right, so Nextflow does multiprocessing. All right, so you need to restrict it a bit. So if you have, let's say, 8 CPUs, maybe you can just reduce this to 4. That's also fine. Okay, just to restrict it, because we are now going to map 12 samples. All right, so for the 12 samples, if you are running everything at once on your computer, it may crash if you don't have a lot of CPUs, or if you don't have a high-end laptop. So you should restrict it. So just to be safe, you can just use 4. All right, for me, I have a high-end PC laptop, so I will just increase it to 12. But If you know you have a laptop with low specs, just try to make it 4. Okay, so it's important you do it this way. All right, take note of that. So I'll just increase mine to 12. Okay, so let's do this. Okay, so again, I'll repeat. If you know you have fewer CPUs, try and then make it 4. Okay, just try to make it 4. All right, so just take note of that. If you use 12 and your laptop keeps on crashing, change this to 4 just to be safe. This one will work fine for you. Okay, so I'll just reverse it back. Okay, now input colon. Here with the inputs, we are going to specify something here. It's going to be longer compared to what we've done so far. So that's how it's going to be. We are going to say tuple. All right. And then what we will do is to say and then with the tuple, what we will do is this. We will say space, we will say val, value into bracket sample ID, comma, we will say path into bracket read1, path into bracket read2, and then we'll say path into bracket index. The index, this is for the index files, the one that we generated from the star index process. So that's how it's going to be. Now, in the next line, it's going to be output, colon, I'll say path, double quote, star, double quotes. In the next line, we'll say path, double quotes, star.bam, double quote, comma, and I'll say emit, colon, bams. We are also giving a label to the BAM file. So BAM files will end with .bam. We are giving a label because we are going to need the BAM files when running feature counts. All right, so that's what we are going to get. When we go to the next line, I'll add scripts. Let me give a space. I'll say scripts, colon, like this, triple double quotes, another triple double quotes. Then we'll put in our star command here. All right, let me just go here. So here we will say star dash dash run thread n. Here I will say 4. And I will say dash dash genome dir, which will be $curly bracket index 2/ or double slash. The next line, I'll say dash dash read files in. So here I'll say $read1, $read2, double slash. The next line, dash dash out some type, the format basically. So we are going to generate a BAM file. It should be sorted. So we say sorted by coordinates / like this. All right, we need to have this also done. Then in the next line, we will say dash dash out file name prefix. So here $curly bracket sample ID, curly brackets, // Another thing we need to add is this one. We are dealing with fastqc files, but these are gzipped. So we need to add another option to tell star that these are gzip files. So we say dash dash read files command, and I'll say zcut. All right, so we need this information also. So this will be the final command for star. All right, so let's just make sure we have everything done correctly, and then we can proceed. All right, so let's do this now. Okay, so we can now proceed. Let's reduce the space here a bit, and then let's scroll down. All right, so now we have the star mapping script done. So let's scroll down to the workflow session, and we can now add the star mapping here. So this is what we are going to add. We are going to map the reads. So the reads we are going to use are the trimmed reads, of course. And so we need to have a way to make sure the information is in the right format and we can push it to star. So how do we do this? We need to take them step by step. All right. So first of all, that's what we need to do. We need to make sure we have information for the trimmed reads. So that's how we are going to get it. All right, we are going to say trimmed. All right, and I'll say .map. I'll bring my curly brackets, and inside we will do some processing. All right, so I will say read 1, read 2 dash, and I'll bring my curly brackets, and I'll say tuple. So tuple, that means in parentheses, and then I will say double quotes $, read 1 dot get file name. I need this information, so I'll bring my curly brackets after. Okay, so parentheses and then curly brackets, and I'll close the single quotes. Make sure to take note of this. All right, then I'll say dot splits into brackets again here. Then in this bracket, I'll say double quote underscore trimmed, double quotes. I need this information. All right. Then we'll bring square brackets, and between those square brackets we'll add 0 because we want the first entry, that record. I'll bring my comma and I'll say read 1, read 2. So this is how the information should be. I'll close the space here. All right, we need to have it something like this. Okay, so we'll proceed. So we'll move to the next line. Just beneath it, we will bring a pipe, and then we will say combine into brackets, and we say star underscore index dot index. We will combine it like this. We will bring a pipe again, and we'll say star underscore mapping to run the process. In the next line, we will say pipe, and we say set curly brackets bumps. We are going to set it like this. All right. So let's do this. Let's exit and then run this command. All right. So let's make sure we have everything we need here. This is the workflow section, so that's fine. All right. So let's exit. Let's save the changes, and then let's rerun Nextflow. All right. So at the moment, that's what we have. If you run we are going to find a new directory called mapping created. Let's execute the script and let's see what I'm talking about here. So let's run it and then let's wait for Nextflow to do its work. So now you will notice we now have trim galore, QC, star index, and mapping because the mapping process has also been added. So let's wait for everything to get done for us. So this will probably take about 3 to 6 minutes, depending on your system. All right, so let's wait for everything to get done for us. Okay, Star has completed its work as well. So we ran the entire pipeline again, and this time we added mapping. So that has also been done. So if you do an ls now, you are going to find a directory called mapping. When you ls into mapping, you are going to find the star outputs. All right, so we have all this information, and also explanation of these outputs is available. So just check my tutorial on star mapping. I explain all these things. All right, so take note of that. So for this tutorial, what we are interested in is the BAM files. We are going to generate the read count. That is the ultimate aim. So now that we have the BAM file, we can now generate the read counts as well using feature counts. All right, so that's what we are going to do next. So let's clear the screen. Let's do an ls again, and then let's open the scripts. So I'll say nano rna-seq.nf, and then we are going to proceed. All right, it's easy and then simple. Okay, once you know your way around. So good job for getting to this section. So let's scroll down to this last section, that is the feature count. So for feature count, we will say process. All right, and I'm going to add the name. So the name, I will just say feature counts. I'll use uppercase. So feature counts, curly bracket starts, curly bracket end, and then in it, I'll say publish dir. I'll bring my read count, comma, I'll say mode, copy. Then the inputs, this is what is going to have. For the inputs, we have the bumps. So path, bumps, path, you add another thing. You will say GTF. Then path, not paths, by the way. So this one, so that will be value. So val into bracket strand. I will explain this later on. Okay. So these are the input information. Now let's go to the outputs. Colon, path, double quote, star, double quote. Here I don't need any emmet because this is the last stage. The next line script, colon, triple double quote, another triple double quotes. Inside we will add our commands. All right, so let's just scroll up a bit to see what we have. Okay, good. So here we are going to run feature counts. So if you are going to run feature counts, then you need the information. So feature counts, this is it, -t for threads 8, -s for strandedness. So here to be $strand. Now with the strandedness, it can be 0, 1, -1. All right, so in this tutorial we are using a strandedness of 0. That's what we are using. All right, but if you have your own data, you need to check with your sequencing facility to check the strandedness. So they will give you the strandedness of the RNA-seq data that you are using. You can also infer. There are tools that can allow you to get the strandedness. All right, so you can visualize using IGV. You can visualize the BAM files to check it. You can also use some other tools. Now, I think you can also use Salmon or so. There's another tool you can use. But anyway, I will try to list some of these tools in the description box for you to check. All right. So here, the strandedness is 0. That is unstranded. That's what we are using here. So it's unstranded. So that means it's 0. So that is why when we are running Nextflow, we say -- strand and we say 0 because we are dealing with an unstranded data. Okay. Now let's proceed. So we are also dealing with paired end data. So I'll say -p and I'll say -- with pairs. And I'll say -t for exon. All right. And by the way, explanation of the feature count command is also available. So I have a tutorial on that. So I will leave that tutorial in the description box in case you want to check more about feature counts. Okay. Now let's add our double slash because we are going to continue the next line. So we say -gen ID -kill, that's mapping quality 10, -a, that's the annotation, that's the GTF. So $curly bracket GTF. And I'll say -o gen _ count. That is the outputs, the prefix for the outputs. Okay, the output file. So we are going to get a file called gen counts. This has the read counts. We are going to get another file called gen count.summary that has the summary files. All right. Space. Now we bring $curly bracket bums. That's what we have. So bums is like this, $curly bracket bums. So BAMS, bums. Okay. Now with feature count, it's possible to also visualize the summary. Okay, to visualize using multiqc. So I'll write a multiqc command to get that. So I'll say multiqc gen counts star. So this will allow multiqc to also visualize the feature counts report for us. So we have feature counts. So what I need to do is to scroll down to the workflow section and then add feature counts. So how do we add feature counts? That's what we are going to do next. All right. So here we need to take note of something. When we run the star mapping, which is here, we assign the entire operation to a variable called bumps. So the bumps will help us to get the bump files. All right. So here we will, because we are rerunning again, I will just say bumps.collect, and I'll say .set final bumps. Okay, so these are the bump files. Okay, then when I come to feature counts, I'll say feature counts into brackets final bumps. We also need the GTF, and then we also need a strand. Okay, so that'll be ref _ GTF command, and we also have the strand. Okay, remember we collected all this information here initially, so that's what we are bringing here. All right, so this becomes the feature count command. So now that we have this, we can save changes and exit. All right. If we run the scripts, in addition to all these files, we are also going to generate another file, another directory called read counts. Okay, so that's what we are going to do. Now, since it's going to be the final execution, what I will do is to delete all these outputs and rerun to make sure that everything is working and we have the outputs. All right, so I will remove the index. I'll remove the mapping directory. I'll remove the QC reports. I'll also remove trimmed, and I'll remove work. I don't need these files. I'll do an ls to make sure that I don't have them there. And now I'm going to rerun. Okay, I'm going to rerun the Nextflow script so that I will generate all the files again. So I'll do this. I'll record this and I'm going to run. Okay, I've already specified all the information. So I will execute this command and I'll wait for Nextflow to do its work. Okay, so now we have trim galop for trim, and we have QC, that's fastqc, multiqc. We have star index, star mapping, and then feature count. So let's wait for everything to get done for us. So it will take between 3 to 6 minutes. That's what it took for me. Okay, so let's wait for everything to get done for us. Okay, Nextflow has completed its work. So we have our final outputs. So if I do an ls, I'll see this here. Let me just clear the screen and do it here again. If I do an ls, I'm going to see all the previous directories that we saw, in addition to the read count directory, which has the read counts. So if I ls into it, I'm going to find my output for feature count. So I have my gen counts summary as well as the multiqc report. So the multiqc report we see here is a visualization of the gen count.summary file. All right. So let's even take a look at these files. So I'll use my file manager to visit the directory. So in the read counts directory, I will see my gen count. So this is the gen counts. I'll open it here. I think I had it already open. Yeah, so this is the file. So this is what we have at the end of the day. All right, so this is the read count. So for each gen, we have chromosome start and strand length, and we also have the read count for that gen per sample. Okay, so across all the samples, we see them here. Now you also notice the headers. Okay, so the headers that we see, we have one here, we also have one here, and these ones, which also has a sample like this, we see it has the name. The name is very long. It has the name of the BAM file. This is something that we can properly format, still using some Linux commands and also still in the Nextflow scripts. Okay, so the script that we made available, it's also properly formatted so that in addition to this file, you have this file which I called gencounts.final. Okay, so when you have this file, all right, then it's already formatted, so you can now push it to the SIG2 to do your analysis. So that's what you have. I repeat, the scripts for this tutorial is available, so you can just download it. The link is in the description box. All right, and then use it. For those who want extra tutorials on Nextflow, you can always book a session with me. Or those who want to build pipelines with Nextflow, you can always book a session with me. Okay, so back to the output. So once you have this output, then it becomes easy for you to do your differential expression analysis using tools like the SIG2, HR, etc. All right. So once you are done with this, what you need to do is to watch this tutorial, which shows you how to perform gene expression analysis using the SIG2 and also using feature count data like this. And also don't forget that with Nextflow, it's always generate this work directory. So what you want to do is to remove this directory. So I'll say rm-fr-work to remove it because it will contain duplicate data which we don't need. So I'll remove it nicely and I'll now have all these which are now my outputs. Okay, so I repeat again, once you are done with the Nextflow tutorial and you have your read count, what you need to do is to watch this video which shows you how to use the SIG2 to perform gene expression analysis, okay, with input data from feature counts.